Welcome to While We Were Distracted, the podcast where we explore topics that often get overshadowed in the rush of daily life. Please take a moment to like and subscribe. It really helps.
Okay, so when you think about volcanoes in the Pacific Northwest, you probably picture, the big mountains, right? Like
Mhm.
Rainier, maybe Mount St. Helens.
Exactly, those iconic peaks.
But there's actually a whole lot happening beneath the waves, too. Today, we're going to do a deep dive into this buzz around Axial Seamount. It's an underwater volcano way off the Oregon coast.
Right, lots of activity there recently. And we'll also, check in on Mount Rainier, which is always kind of on our radar.
Yeah, definitely. So for this, we've looked at some recent news reports and also a really interesting YouTube discussion that covered both of these areas.
hmm And our mission really is to pull out the key stuff, the most interesting information about what's going on, look at the science a bit, and maybe address some concerns you might have.
But keep it engaging, right?
Okay.
Not just a dry lecture.
Definitely not. Let's try and make sense of it all.
All right, let's start underwater then. Axial Seamount. So picture this. It's about 300 miles off the coast of Oregon.
Way out there.
Yeah, and it's deep. Like more than 40 and 900 feet below the surface. It sounds kind of wild.
It really does. And the thing is, it's actually the most active underwater volcano we know about in this whole region.
And it's not just active, it's fundamentally important, right? I saw a quote from Maya Tolstoy, a geophysicist.
Oh, yeah, she pointed out that something like 2/3 of the Earth's surface was actually formed at these mid-ocean ridges, places just like this.
Wow. So Axial Seamount isn't just some oddity. Professor William Wilcott called it a genuine hotspot.
Yeah.
It's like a window into how the planet builds itself.
Exactly. It's a live example of these massive geological processes.
And speaking of live, there's a prediction, isn't there, about an eruption.
Yes, that's the big news. Scientists are saying it's likely to erupt probably before the end of 2025.
Before the end of 2025. That's soon.
It is. And it's apparently the first time they've made a long-term prediction for an undersea eruption like this.
That
It's not just guesswork either. They're seeing some really clear signs.
okay, what are they seeing down there?
Well, for one thing, a huge spike in earthquakes. Small ones, but lots of them. Some reports say over 1,000 little tremors a day.
1,000 a day. Yeah.
And the volcano itself, the seafloor above it, is actually rising. It's inflating.
Inflating, like swelling up.
Sort of, yeah.
Yeah.
It's a classic sign that magma is accumulating beneath the surface, pushing it upwards. They've also picked up more quakes starting deeper down below the main part of the volcano.
So it's like the whole system is getting energized.
Pretty much. All the indicators are pointing towards increasing pressure and activity.
It's amazing we can even know this, given how deep and far out it is. How are they tracking all this?
Well, that's thanks to something called the Ocean Observatories Initiative's Regional Cabled Array. It's this incredible network, basically the world's first underwater volcano observatory.
Okay.
It's got around 150 sensors connected by cables spread out across the tectonic plate down there. They measure everything in real-time: earthquakes, seafloor shape changes, temperature, chemicals.
So it's like having a permanent monitoring station right on top of the volcano.
Exactly. It gives them this constant stream of data, an unprecedented look, really.
Okay, now the obvious question, I guess. Underwater volcano, potential eruption. Should people on land be worried? Tsunamis, big earthquakes reaching the coast.
Right, that's the crucial safety point. And the consensus among experts is pretty clear. No, it's just too deep and too far away.
So that nearly mile of water above it makes a difference.
A huge difference. And the 300 miles distance. The energy from an eruption down there just isn't expected to create a significant tsunami or trigger major quakes that would affect coastal communities. Multiple sources emphasize that.
Okay, that's really good to hear, a big relief. So if it's not a direct threat to us on land, what actually happens down there when it erupts? You mentioned it's this active place.
Yeah, it's fascinating. Around the hydrothermal vents, these sort of underwater hot springs, there's this whole unique ecosystem. Deborah Kelly, who directs that cabled array, called it an oasis of life.
An oasis in the deep ocean.
Absolutely. These vents spew out warm, chemically rich fluids from inside the Earth, and that forms the base of a food web. Tiny microbes actually live off those chemicals. They use the volcanic gases for energy.
Instead of sunlight.
Exactly. And then you get all sorts of other creatures feeding on them or living in that environment. Weird tube worms, spider crabs, clams, fish. Even octopuses hang out there.
It sounds incredible, like an alien planet. So what does an eruption do to that oasis?
Well, during an eruption, you get more quakes, obviously, and new lava flows spreading across the seafloor. You also get these things called snowblowers.
Snowblowers. Underwater.
Yeah, it's these plumes of warm fluid that are full of those microbes, looks like white smoke or snow billowing out. An eruption definitely disrupts the immediate area. It could impact the smaller creatures and bacteria right at the vents.
So it's disruptive, but maybe not totally devastating.
It seems life down there is pretty resilient. These are extreme environments anyway, so there's this cycle of disturbance and recovery. The lava creates new ground, new vents form, life finds a way.
Right. So for the scientists monitoring this, it must be like, well, like Christmas coming early, right?
Oh, absolutely. It's a golden opportunity. A chance to watch a volcanic eruption unfold in real time, basically from start to finish, with all those sensors running.
What are they hoping to learn specifically?
Well, all sorts of things, like what exactly triggers these eruptions. They're looking at subtle things, like maybe the influence of ocean tides or gravitational pulls from the sun and moon. Getting data during an actual event is crucial for testing those ideas.
And that could help predict other eruptions.
Exactly. Improving the models, understanding the warning signs better, both for underwater volcanoes and maybe even applying some lessons to volcanoes on land. And get this, there's talk they might even try to live stream the eruption.
Seriously. Live video from a mile underwater during an eruption.
That's the hope. Can you imagine? Giving everyone a view of this raw geological process.
That would be absolutely incredible. Has Axial erupted before that we know of?
Yep. They recorded eruptions in 1998, 2011, and again in 2015. Each one taught them more. And Axial's a bit special, too. It sits over what they call a hotspot, a plume of extra hot rock coming up from the mantle.
Ah, so it's not just about the tectonic plates pulling apart. It's got this deeper heat source.
Right. That helps explain why it's so consistently active.
Okay, fascinating stuff happening way out there. Let's shift gears now and come back closer to home, Mount Rainier.
Right. The big one overlooking Seattle.
Yeah, one of Washington's 4 active volcanoes and, less than 70 miles from a major city. What's the latest there? Still quiet.
According to the USGS, yes. Their official word is it's totally in a state of background activity, so no immediate worries right now.
Background activity, meaning just the normal low-level rumblings and gas release.
Exactly. The normal state for an active but not erupting volcano. But, and this is important, just because it's quiet doesn't mean it's ignored. It's monitored constantly.
How do they do that? What kind of monitoring?
Oh, they have a whole network of instruments. Infrasound sensors, which listen for low-frequency sounds that eruptions or lahars might make. Lots of seismic sensors to detect earthquakes, even tiny ones.
Okay.
And gas sensors, too, checking the types and amounts of gases coming out. Plus, they've put extra sensors on the southwest side, specifically looking for landslides that could trigger mudflows.
Right, mudflows or lahars. We hear a lot about those with Rainier. But first, if Rainier were to start waking up, would we know in advance?
The general scientific thinking is yes, almost certainly. For a major eruption, they'd expect to see clear signs building up, likely for months beforehand. Changes in earthquake patterns, ground swelling, gas emissions.
So it wouldn't just suddenly blow without warning.
Highly unlikely for a large event. The monitoring is designed to catch those precursor signals well in advance.
Okay, that's reassuring. But if it did erupt eventually, what are the main hazards we'd face, especially thinking about Seattle nearby? Is ash the big one?
Ashfall in Seattle is definitely possible. Yeah, it would depend heavily on the size of the eruption and which way the wind was blowing at the time.
But what about lava flows or those mud flows reaching the city?
Experts generally say no, not likely for Seattle itself. The really significant risks, the most immediate dangers, are for the communities built in the river valleys leading away from the mountain, the foothills.
And that's where the lahars come in, those volcanic mud flows.
Exactly. Lahars are a huge concern with Rainier. Because it has so much ice and snow on it, an eruption could melt that very quickly, mixing water with volcanic rock and debris.
Creating these massive, fast-moving mud flows.
Yes, and they are incredibly destructive. They can travel for miles, burying everything. Think about the devastation from Mount St. Helens's lahars. That's the kind of thing they worry about in places like Ording or Puyallup, towns built on old lahar paths.
It's a pretty scary thought. Are those communities prepared?
There's definitely been a lot of work on that. Evacuation routes, warning systems, public education, regular drills in schools and communities in those high-risk zones.
So people living there are aware of the risk.
Yes, generally. And it's also important to know that these lahars, these mudflows, can sometimes happen even without an eruption.
Oh.
Just a large landslide, maybe triggered by heavy rain or an earthquake, could destabilize water-saturated material on the volcano slopes and send a mudflow down. That's why those specific landslide sensors are there too.
Right, so it's not just about eruptions. When was the last time Rainier actually had a major eruption?
The last really significant one was quite a while ago, about 1,000 years back.
1,000 years.
Yeah. But geologically, that's not that long, and if you look at the whole Cascade Range, on average, one of those volcanoes erupts maybe once or twice a century. So vigilance is key.
Okay, so summing this up, we've got Axial Seamount, the underwater one, looking like it's getting ready to erupt relatively soon. Huge scientific interest, but
Yeah.
low risk for us on land.
Right. A fascinating natural laboratory.
And then we have Mount Rainier, currently quiet in a background state, but because of its potential hazards, especially those lahars, it needs constant, careful watching.
That's a good summary. Two very different volcanic situations in the same region, really. One posing an immediate, though distant, event, the other a long-term potential hazard nearby.
And studying both helps build a bigger picture of how these things work.
Absolutely. The science benefits from looking at both types, underwater and on land. And you see a lot of collaboration in the research community sharing data and insights.
That's pretty amazing science.
Yeah.
Okay, so let's wrap up the main takeaways from our deep dive today. Axial Seamount, eruption, likely before end of 2025, great science opportunity, maybe even live streamed, but no expected impact on land. No tsunamis, no major quakes felt ashore.
Check. And Mount Rainier. Currently quiet, background activity only. But it's heavily monitored because future eruptions could pose risks, mainly ashfall and especially those destructive lahars in the foothills. Systems are in place to provide warning.
Right. Which leads to maybe a final thought for you listening. Think about how these two very different volcanoes, one hidden deep in the ocean, the other this, majestic giant watching over us, how they both show just how dynamic our planet is, constantly changing, building, reshaping itself.
It makes you wonder, doesn't it, what other huge geological processes are happening right now, unseen under the oceans or deep beneath our feet, that are continuously sculpting our world. It really highlights how interconnected everything is, Earth systems working in ways we're still just beginning to fully understand.
Please take a moment to like and subscribe. It really helps.